Welcome to Geometry 1.03 Notes. We are talking today about parallel lines. So hopefully you guys have seen parallel lines in some other math classes before, so we're going to review to start off. I'm actually going to give you, to start off our notes, a pair of lines that are not parallel. And I want to talk about the different names of the angles that we discuss when we typically talk about parallel lines. So I'm going to call this line L, and usually we can just name a line either with 2 points that are on the line or a letter on the edge of the line here. Usually it's an italicized letter. So I'm telling you here that these are non-parallel lines, L and M, with a transversal. And all a transversal is that line that passes through both parallel lines. Transversal. And that one's T. So with non-parallel lines, we still have vertical angles, linear pairs, alternate interior, alternate exterior, corresponding angles. The thing is, though, that they're not always going to be congruent like they would be possibly if we have parallel lines. So first we'll start off with vertical angles. Now these are actually always congruent no matter whether the lines are parallel or not, always congruent. So what I'd like to do first is just list out some vertical angles. So I'm going to put some numbers to represent these angles here. 5, 6, 7, 8. So some vertical angles could be angle 1 and angle 3. Angle 2 and angle 4. You'd have angle 6 and angle 8, and angle 5 and angle 7. So those are all your vertical angles, and those would be congruent. Next, we're going to talk about a linear pair. So linear line, you see in that word, linear. So this just means a pair of angles. So two angles that form a line. So these ones, if you added them together, they would give you 180 degrees. So you want to look for which angles form a line. So look at L right here as a straight line. So we have angle 1 and angle 2 together form a linear pair because angle 1 and angle 2 create that entire line. So they'd add to 180 degrees. Angle 3 and angle 4 are a linear pair, because they also would add to 180 degrees. Looking at it kind of sideways here, angle 2 and angle 3 are a linear pair, as is angle 1 and angle 4. So I just did this top section of all the linear pairs, but you also could do it on this bottom section right here on line M. So I'm not going to write those all out right now, but 5 and 6 would be a linear pair, 6 and 7 would be a linear pair, 7 and 8, and also 5 and 8 would be a linear pair. Next, we're going to talk about alternate, and I tend to abbreviate this usually, but because it's the first time we're writing it out in our notes, I'll write the whole thing. Alternate interior angles. And I like to call these our Z angles because they form the letter Z if you trace the diagram. So if we trace here down our transversal, and because they're not parallel, it's going to be kind of a funky looking Z. But here's your Z, and we're looking in like the armpits of your Z, I like to say. So in those little nooks in your Z, in the armpits of the Z, those are going to be your alternate interior angles. So also to remember, you can think alternate. They're on alternate sides of the transversal. Interior means they're both inside the two lines. So we have alternate interior angles here. So angle 4 and angle 6 would be alternate interior angles. But because these two lines are not parallel to each other, they are not congruent. 4 and 6 are not congruent here. If lines L and M are parallel, then 4 and 6 would be congruent because they're alternate interior angles. And we also have a Z over here. And in the armpits of our Z would be angles 3 and angle 5. Those are alternate interior. Next, we're going to do alternate exterior. And those, again, if you look at alternate, they're on opposite sides, or alternate. Some people call them opposite exterior angles. They're on opposite sides of the transversal, and they're going to be outside on the exterior of the two lines. So this is our transversal right here. So 8 is outside the two lines, and on the opposite side of the transversal, which angle is also outside the two lines, and that would be 2. So 2 and 8 are on opposite sides of the transversal, and they're both outside of the two lines. So angle 2 and angle 8. And then another pair, hopefully you're looking and finding another pair, would be angle 1 and angle 7. And then the last ones we'll talk about in this section are our corresponding angles, which are the ones that probably students forget the most often. And corresponding angles, I like to think of those as the F angles because they form a capital letter F. So let's take a look there. So this is, I know I've got a lot of colors going on here. This is my part of my F right here and here. Again, they're not parallel, so it's not a perfect F. And then you're looking in the armpits of your F. So here and here. So corresponding, they don't have the word alternate in them, so they're not on alternate sides of the transversal. They should be on the same side of the transversal. And they don't say both interior, there's no word exterior in there, so they're not both inside, they're not both outside. So you've got one of each. So 3 and 7 are corresponding angles. And then looking at your picture, you should be able to find a few more pairs. So 2 and 6 would also be a pair. 1 and 5, and 4 and 8. So they should be on the same side of your transversal, one inside, one outside. Angle 2 and angle 6, and angle 1 and angle 5. So we're still talking about that same diagram up there, but this time I'm going to tell you that the measure of angle 1, I'm going to assign that a value. I'm going to say that it's 110 degrees, and the measure of angle 6 is 20 degrees. And I want you to find all the angles that are missing there. So again, these are not parallel, so that is why you're going to need to be given at least 2 angles. Therefore, those 3 dots mean therefore need 2 angles given. All right, so looking at our picture up here, we've got the measure of angle 1 is 110 degrees, and the measure of angle 6 is 20 degrees. So we could do vertical angles to find angle 3 would also be 110. Then we have linear pair here, so we could do 180 minus 110 to get 70. We could do a linear pair again to find 4, or we could do vertical with angle 2. Again, since they're not parallel, we do not have alternate interior angles congruent. They're not congruent here, one's 70 and one's 20. So now I'm going to work on the bottom line here, line M. So across from 20 would be my vertical angle, also 20, and then 180 minus 20 gives me 160 because those form a line, a linear pair together. So that's what I'm looking at here. So you could write out all of those. So the measure of angle 2. Again, we put a little M in front of the measure, in front of angle 2 to indicate measure of angle 2. And we do that whenever we have an equal sign. So important here, since they're not parallel, we had to have 2 different angles. 7 is 160. We already had measure of angle 6, and the measure of angle 8 is 20 degrees. All right, now I'm going to tell you that the measure of angle 1 is 150 degrees, but this time I'm going to tell you that M is parallel to L. Let me fix that. It is parallel to L. And that is very important, because now you don't need 2 angles, you actually only need 1. So I'm actually going to draw this picture out over here. So M and L. Also, if I didn't mention it already, these lines should be parallel, and to mark those, you use those little arrows. If you had another set of parallel lines, you would use double arrows on those, or you can use double here. All right, we have still 1, 2, 3, 4, 5, 6, 7, 8. And we are given that the measure of angle 1 is 150 degrees. So now let's talk about the measure of angle 2. Well, that's supplementary to 1, so 180 minus 150 is going to give us 30 degrees. Measure of angle 3 is vertical to angle 1, so that's also 150. And the measure of angle 4 is vertical to 2, or supplementary to 3, 180 minus 150 would give us 30. Now let's go to the bottom. We've got the measure of angle 5 we need to find. So this was 150, this was 30, and this was 30. So to find 5, probably the most common one students use is alt interiors. So find that Z, trace it, and look for the armpits of the Z, or what's on opposite sides of the transversal and both inside the parallel lines. And that would be that it's equal to 3. So that's also going to be 150 degrees. The measure of angle 6, you could do that it's a linear pair with 5, so they're supplementary, and 180 minus 150 gives us 30 degrees. You could have done alternate interior angles with angle 4 to get that it's 30. A lot of different ways. You could have done corresponding angles with angle 2 to get that it's 30. Measure of angle 7, maybe let's use corresponding. So now that I know angle 3 is 150, it's corresponding with 7. So 7 is also 150. So a lot of different ways that you could get these answers. And then measure of angle 8, you could do it as vertical angles, linear pair, alternate exterior, alternate interior, any of those. So next I want to just write out the theorems, because these are really important, especially as we get to proofs that will be coming up. So our theorems, and these are going to be a little bit redundant right here. It's very important when we write these theorems that you have this first part, because you're going to be writing these out a lot when we do parallel lines proofs. So in order for these theorems to be true, the if part has to be true. So if two lines are parallel, it only works if they're parallel. Corresponding angles will be congruent. If two lines are parallel, then alternate interior angles are congruent. If the two lines are parallel, alternate exterior, and here I'm abbreviating, if that's fine if you want to abbreviate as well, as long as you understand what those mean. Alternate exterior angles are congruent. If two lines are parallel, we also know same side interior angles are not congruent, but they will be supplementary. So they'll add to 180 degrees. So again, looking at this, if I've got 1, 2, 3, 4, 5, 6, 7, 8. Corresponding would be 3 and 7, 2 and 6. Alt interior we've talked about would be 4 and 6 or 3 and 5. Alternate interior, that is. Alternate exterior would be 2 and 8 or 1 and 7. Same side interior angles. So that means on the same side of the transversal, and they're both inside. So that would be angle 3 and 6. So 3 is up to angle 6, meaning they add to 180 degrees if you added those two angles together. And the last theorem we're going to write out today is if two lines are parallel, same side exterior angles are going to be supplementary. And again, that means adds to 180 degrees. So same side exterior would be angle 1 and angle 8. So those would add to 180 degrees, or angle 2 and angle 7. They're on the same side of the transversal, and they're both on the exterior. Number 3, given that J is parallel to K. Find the values of X and Y. So we've got two lines here, J and K. And we have a transversal going through them. This angle up here is 3 times the quantity of X plus Y. Here is 5X. And this one's 4X minus 9. I want to mark here my two lines are parallel to each other, so I do the arrows. And I want to try to make this as easy as possible for myself. So I see this one has an X and a Y in it, so I want to try to avoid using that if possible initially. So you might want to just go through and think about all the different equations you could write. So I might say, okay, well, these two angles are alternate exterior angles, so I could set them equal, but that would give me an X and a Y. What do I know about these two angles? Well, these two angles form a line. They form a linear pair. So together I could add them and set them equal to 180. Well, that looks good because there's only one variable then, so we could solve that. So let's do that one. So 5x plus 4x minus 9 equals 180 degrees. So again, important, there's only one variable. So I don't need a system of equations, so it makes everything a lot easier. So you don't need a system of equations. Now just combine your like terms. We get 9x minus 9 equals 180. 9x equals 189. X equals 21. Did I answer the question? Well, I answered part of it. I got X. I still need to find Y. So to find Y, I need an equation because right now I don't have any equation that has Y in it. So I need an equation with Y. So maybe we use that first equation that we thought of. So 3 for alternate exterior angles. And they're only congruent if the lines are parallel, but the lines are parallel here. So 3 times the quantity X plus Y equals 4X minus 9. Let's distribute our 3 in. 3X plus 3Y equals 4X minus 9. Subtract your 3X from both sides. Get 3y equals x minus 9. And then we need to just substitute in that 21 in for x. So 3y equals 21 minus 9, or 3y equals 12. Divide both sides by 3, and y equals 4. So we've got y equals 4 and x equals 21. Number 4. Given J is parallel to K, find X. So here are our two parallel lines, J and K. Here's our transversal. Here's 2X. Okay, so a couple different ways you guys could figure this out. You need to figure out the relationship between them. So when we're talking parallel lines, so let me label these again, you're either going to have the angles be equal to each other or they're going to add to 180. So we need to figure out which case this is. So most students feel really comfortable with alternate interior angles. So you might say, oh, well, I see 2x inside here. Where's its alternate interior angle? And look for that z. Well, alternate interior would bring me over here. Now I can better see the relationship between these two. Now that they're right next to each other, I know that they form a linear pair, which means they're supplementary, which means they add to 180 degrees. You could do it in different ways. You could put 8x minus 5 down here because those two are corresponding. So you know this one must also be 8x minus 5. And then look at these two to see that they're supplementary. So a bunch of different ways you could do it. But bottom line is we know that these two are not equal to each other, but that we want to add them together and set them equal to 180 degrees. Pause the video here. Take a moment to combine your like terms and solve for x. Okay, and you should have gotten x equals 18.5. For this one on your paper, you should have all the work written out to get that answer. And the last one we're going to do today here, giving you another diagram. So in the diagram below, M is parallel to N. And I think I'm just going to write in the angles that I'm going to give you, and I want you to find the measure of angle PAR. So I'll keep everything that I'm giving you in green, and then I'll switch to a different color. So we have M and N. Again, mark those parallel to each other. Here's P. That's a segment that goes down to S. And Q goes to R. Giving you this angle up here is 148 degrees, and this angle is 104 degrees. So in geometry, what's usually best is to just kind of dive in. You might not necessarily find what you're looking for right here, right away, but just find anything you possibly can. And then as you find more and more, we hope that that helps us to find what it is they're asking us for. So you might start here by saying, okay, well, I see a linear pair here. These two form a line. So I might do 180 minus 104. So that would give me 76. I might do the same up here. And that would be 180 minus 148. Bless you. And that would be 32. We know that these two lines are parallel to each other. So if I trace here, again, tracing is always really helpful. Find the Z, because that one's usually our go-to. So now I have a Z, so this angle must be 32. Let's find our Z over here. I've got where the 76 is. If I find the Z with that, that means this one's going to be 76 degrees. And now let's take a look again which angle we're trying to find. So PAR, this one out here. So in my head, what I'm thinking is if I can find this angle right here, then I can find this angle. So once I find this, I just subtract it from 180 to find the angle over here. So I can now find this angle because I spy with my little eye a triangle. And I know that in triangles, the angles are going to add to 180 degrees. So I'm going to take 76 plus 32 and subtract that from 180. And that's going to give me my 72 degrees. And now to find the measure of angle PAR, I see that these two angles are a linear pair, so I'm just going to subtract 72 from 180, gives me 108 degrees. So the measure of angle PAR is 108 degrees. All right, and that is your parallel lines notes, which are very, very important. Hopefully those made sense and that you remember the stuff that you've learned in the past about parallel lines. The big things you want to remember: alternate interior, alternate exterior, corresponding, and of course your same side interior, same side exterior. Make sure you know which ones are congruent when the lines are parallel, which ones add to 180 when the lines are parallel. All right, if you have any questions, make sure you send me a message, and hopefully I will see you soon. Pi out.